Okay, here we go. Chapter 4. Oh, you're just in time.
We were at Gardner's Room. Yeah, check your email. It's hot.
I'll tell you what it's called. Chapter 4 is called More Derivatives. I'm not kidding you. It's actually what the book calls it. More derivatives. Back in the olden book, the one I used to teach out of, the one right before this book, they had chapter 3 and chapter 4 as one chapter 3, and it was pretty terrible. It went all the way to 9 lessons. We went to 3.9. Yeah, terrible. So they've broken it down into 2 chapters, derivatives and then more derivatives. So by the end of this chapter, you will be able to take the derivative of pretty much anything. Okay? So you know how to take derivative, trig stuff, power rule, radicals, all that stuff. Now today we're going to learn a little something called the chain rule. Chain rule. All right. Unfortunately, the book didn't give you a nice little paragraph about how awesome this chapter is going to be. They just went right into it. Maybe because it's like more derivatives, like we're still doing the same stuff. When we get to chapter 5 for second semester, that's when we start applying all the derivatives that we've learned so far. Okay, so right now we're still learning the basics, and then in chapter 5 we'll start really getting into applying what we know. All right, so here we go. Now, here's what the chain rule is. We have taken derivatives of y equals sine of x, and we've taken derivatives of y equals x squared minus 4. But we have not taken any derivatives of something that combines the two, like a composition of functions, like y equals the sine of x squared minus 4. Okay? And when you take the derivative of a composition of 2 functions, you have to do something called the outside-inside rule. So for example, if f of x is equal to h of g of x, okay? Like this up here. Let's say that this is h of x, y equals x squared minus 4 is g of x, and then we want to take the derivative of h of g of x. Here's how you take the derivative. It's called using the chain rule. So f prime of x is going to equal, and it's the outside-inside rule. You're going to take the derivative of the outer function, leaving the inside exactly as is, times the derivative of the inner function. That's all it is. Okay? Sometimes you'll have more than one inner function. You'll have to do it again. Chain rule. It's a chain. Okay? So let's go ahead and let's do that one up there. Number 1. Let's suppose that f of x is equal to the sine of x squared minus 4. Okay. When you kind of stand back and look at this, you can see that there are 2 kind of separate functions going on, right? You have an outer function, which is sine, and an inner function, which is x squared minus 4. So here's how the chain rule works on this problem. F prime of x is equal to, you take the derivative of the outer function. So the derivative of sine of stuff equals cosine of stuff. Leave stuff alone, okay? Times the derivative of whatever's inside. And what's the derivative of x squared minus 4? 2x. And that's your answer. So you get 2x, we'll move that to the front, cosine of x squared minus 4. That would be it. Pretty good, huh? That's called the chain rule. It's really an amazing rule. It really is.
You have to get proof for it?
No. Is there? That's probably beyond the scope of this text. That's what the book always says when they have something that's super hard that they don't want to explain. They say, oh, that's beyond the scope of the text.
What does that mean?
It means that you won't get it. Mm-mm. I probably did prove it at one time, because when you get after Calc 1, Calc 2, Calc 3 differential equations, you take analysis or advanced calculus, where you prove all the theorems and things you've learned. It's really awful. I got a C in that class today. Good job. All right, number 2. C's get degrees. That's right. Let's try this one now. Ooh, here we go. You ready for it? Y equals cosine to the 4th x. Okay, do you know that cosine to the 4th x, you might want to rewrite this. You might want to rewrite this like this. This is the same thing as cosine x to the 4th. Do you all agree with that? You learned that in trig, hopefully. that when you did y equals sine x times sine x, we didn't write sine x squared, we just write sine squared x. It's the same thing, okay? So if we have this, this is really cosine x to the fourth. So now you see there's an outer function. The outer function is to the fourth, like a function to the fourth power, and the inner function is cosine x. So let's go ahead and take the derivative of this. So y prime. Take the derivative of the outer function. The outer function is just a power rule. We don't even care what's inside of here. It's something to the fourth power. What do you do with that fourth power? You bring it down, you leave stuff alone, and you subtract 1 off. Isn't that right? Isn't that what we do with the power rule? Yeah. You bring the 4 to the front, leave it alone inside, subtract 1 off. And then times, so that's the derivative of the outer function, times the derivative of the inner function, which is negative sine x. Good. And that's it. So this is y prime equals negative 4 sine x. And you can write this as cosine cubed x like that, or you can leave it as cosine x cubed. How you feeling on these? You feeling them? Pretty good? Wonderful. Good. Number 3, they get harder. Don't you worry. How about something like this? This is going to look almost the same thing as the last one, but it's not. Y equals cosine of x to the fourth. Do you see the difference on this one?
Yeah.
Yeah. So you always, what I do about these is I kind of stand back and look at them and I think, okay, what's my game plan here? What am I going to do? Instead of just jumping in and just doing it, I recognize that cosine is my outer function this time and x to the fourth is the inner function.
How do you know what your outer function is and what your inner function is? How do you differentiate?
Yeah, so x to the fourth is being surrounded by the cosine, so that's the inside function. Over here, the fourth was on the outside and cosine x was on the inside, so that's the inner function. All right, you want to try this one? Sure you do. You try it. You got this. Outside, inside rule. Okay, maybe? Did you get it? No? All right, so outside, inside rule. Take the derivative of the outer function. What's the derivative of cosine? Negative sine. And don't do it at the same time. That's another thing that people will do. You want to do just one at a time. So I'm taking the derivative of cosine, leaving that x to the fourth alone, times the derivative of the inner function, which is 4x cubed. And then we want to rewrite this as negative 4x cubed sine of, and you can put that in parentheses, x to the fourth, like that. Anybody get that? Yeah, good. Quite a few. Okay, number 4. Want to have a really tricky one? Sure you do. F of x is equal to, it's not so bad, the square root of 2x minus 7. F of x is equal to the square root of 2x minus 7. All right, for this one, you want to start by rewriting this so that it's in its exponential form, okay? Just like you would if you were taking just the square root of something. So 2x minus 7, and this is all raised to the 1/2. All right, so now we're ready. Do you see the inside and you see the outside function? So you do outside first, outer inside rule. So outside first. So the derivative would be to bring the 1/2 down to the front. And then don't forget to subtract 1 off. So 1/2 minus 1 is negative 1/2. And we're going to have to fix that in just a minute. And then times the derivative of the inside, which is 2. Okay? All right, so then what I get is the 1/2 and the 2 will reduce, leaving me with f prime of x equals 1 over the square root of 2x minus 7. You do not need to rationalize that. Sure. I'll let your brain catch up. I bet you can figure that out. Did you figure it out? So to the negative 1/2 brings it down, and then to the 1/2 means square root. All right, doing pretty good? Yeah.
Since 1 over that, can we cross out the 2's?
Yeah, it's 1/2 times 2,
Which is 1. Does that
which is 1.
The answer is in the denominator.
Right, so this is to the negative 1/2.
Uh-huh.
So the whole thing has to move down,
Oh, okay.
and then I get square root. All right, number 5.
Can you put it to the 1/2?
What's that?
Can you put it to the 1/2, or do you have to square root it?
It's either way. I think I said on the test, even no fractional exponents in your answer. So you want to rewrite it as square root, cube root, stuff like that. All right, let's try. I've got a really good one next. That one's not a good one. Ooh, here's a good one. Are you ready for it? Okay. Number 5. Let's do y equals x times the tangent of 4x cubed. X times the tangent of 4x cubed. All right, this is going to involve quite a few rules that we know. It is product rule. Yep, we got a dot right there. It's definitely product rule, and then it's also going to be chain rule. Chain rule for this part right here, okay? All right, so here we go, y prime.
Wait, so then do you have to do the product rules first?
You do it at the same time. Because, product rule is A times B prime. When I'm doing B prime, I have to do chain rule right there. Yeah?
Okay, can you just try?
Oh, I'm trying to. People keep talking and interrupting me. Sorry. You guys are like in a bad mood. Here we go. Product and chain rule. So this is A right here, and this is B right here. So we're going to do A times B prime. Okay, so we're going to take the derivative of the tangent of 4x cubed. So the outer function is tangent. Do you remember what the derivative of tangent is? Secant squared of stuff. Leave stuff alone, okay? Just the derivative of the tangent part, leaving the inside as is. Times now the derivative of 4x cubed, which is 12x squared. Good. Plus. So that's just A times B prime. Now we have to do B, which is the tangent of 4x cubed, times A prime, which is simply 1. And then you want to simplify this. It's not that bad. We need to get x times 12x squared together. That makes 12x cubed. Secant squared of 4x cubed, nothing to simplify there. And then just simply plus tangent of 4x cubed. Could you do that? Something like that? Yeah? It's getting real complicated, isn't it? We kind of jumped up a notch today. Yeah, next level. We powered up. Every single chapter we level up. Number 6. Too bad we can't just jump into that star to make us go through all this stuff. X squared times 3x plus 4 cubed. Would you like to try this one?
Yes.
Okay.
I'd like to watch you try.
Shh. All right, we're going to do, this is A, and this is B, okay? So we're going to do A times B prime. So here's A. B prime is to bring the 3 down, leaving the inside alone, and subtract 1 off. Remember, just do it one at a time, one derivative at a time, times the derivative of the inside, which is 3. Okay, so that's AB prime, plus B, which is 3x plus 4 cubed, times A prime, which is 2x. Please do not ever spend time foiling or cubing things out. Just leave it. So you have y prime equals 9x squared times 3x plus 4 squared plus 2x times 3x plus 4 cubed. What happened?
Wait, what about the other 3?
Hold on. Which other 3? 3 times 3?
Yeah. The 3 times 3x plus 4 squared. Shouldn't it be
Oh, this times 3 times x squared.
okay.
Did I do it right?
Yeah.
Okay. So what are you looking at?
The second third.
Right here?
Yeah.
X squared times 3 is 9x squared.
Okay, but don't you? Oh, okay.
And then, you know what? Sometimes this might be Drugs already. This, dang it.
It's actually just steroids.
This might be on your test as like a multiple choice section, and you might not see the answer because sometimes what they'll do, I don't think I do this too often, is they'll look at both of these and they'll say, oh, I can factor out, what can you factor out from both of them? A 3x plus 4 squared. And they'll do this, it's really weird. I remember a problem like this in college where they factored that out and then they left that with 9x squared plus 2x times 3x plus 4. And I kept looking for the correct answer. Like I had this answer, and this answer was actually the real answer. Or sometimes they'll even distribute and do all this stuff, and you're like, what? Yeah, anyways. So we're going to go ahead and stop right there for that problem, and that's it. How many of you guys got that right? Did you get that right in the back? Yeah, okay. All right. Now, number 7, I'm going to do a three functions inside of one. Okay? So this is, it's not my fault. I didn't write the curriculum. You cannot get mad at me. All right, here we go. Y equals, no, 1 plus cosine of 4x to the 3rd power. Now let's talk about this a minute. Do you see the 3 functions here that I'm talking about? There are 3 of them. You do? One person says yes. There's the outer function, which is cubed. There's also a cosine, and then there's the 4x. So you're going to have to do chain rule a few times, okay? So let me show you. Let me walk you through it. First, start with the outer function. Bring that 3 down to the front, leaving the inside alone, and following through with the power rule by subtracting 1 from 3. Okay? We're all okay with that. The 3 moves to the front. Now times the derivative of the inside. Derivative of 1 is 0. The derivative of cosine of 4x is negative sine of 4x times 4.
What did you before?
Mm-hmm. What's the derivative of cosine of 4x? Cosine of 4x is chain rule also. So the outer function is cosine. The inner function is 4x. So the derivative of cosine is negative sine, leaving 4x alone, and then times 4. Chain rule, chain rule.
You get the 4 after Austin hits his drive.
It's really good, right? Oh, Austin says 4 every time he hits his drive.
Yeah.
All right, so we get negative 12. We can bring the negative 12 out front. 1 plus cosine of 4x squared times the sine of 4x. That's the answer. Did you not understand that one? You did? There's 3, okay? Anytime you have the cosine of something other than just x, you have to take the derivative again. So cosine of 4x, the derivative of that, if you want to put parentheses around it to kind of remind you, you can. Number 8. How many are there, you ask?
7.
As many as I want, I reply. Okay, here we go. Let's do... Ooh, this is really good. Y equals secant squared of 5x minus 2. This is pretty bad. Okay. For me, when I used to do these, I would change them. I'd write them so that I could see what's happening. So like for this, anytime I had a cosine squared or cosine to the 4th, secant, I would just put that on the outside. So this is secant of 5x minus 2, all of it squared. Do you agree with that? You should agree with that. That's true. The secant squared is the same thing as pulling it all the way out and squaring it. Now there are, again, 3 different functions in here. There's an outer function of 2. There's an inner function of secant, and then there's an inner function of 5x minus 2. And we're going to take the derivative and use chain rule and do them all separately, okay? Here we go. Let's do it together. Y prime equals. So I'm just doing the outside, which is the power rule. I'm going to bring the 2 down to the front times the secant of 5x minus 2. When I subtract 1 off, it's just to the first power, so that doesn't matter. That's just the outer function. Times, now I'm going to take the derivative of the secant of 5x minus 2. Well, what's the derivative of secant? Secant tangent. So this is going to be secant of stuff, tangent of stuff. Remember, you have to leave the inside alone when you're taking the derivative of that outer function. And then now I have to do times the derivative of this inner function right here, which is 5. Okay, let's now put it all together. 2 times 5 is 10. Secant of 5x minus 2 times secant of 5x minus 2 is secant squared of 5x minus 2 times tangent of 5x minus 2. That would be your simplified answer. Beautiful. Aren't these fun? No. Number 9.
How many already do?
As many as I think I should.
7.
No.
7?
Sassy.
Sassy?
Crazy. How many do you have planned?
13.
Just one more.
Is that it?
I think I took out parametrics this year.
Yay.
Okay, here we go. Last one. F of x equals x divided by the square root of 1 plus x squared. Okay, I did. We are going to combine quotient rule with chain rule, power rule, and radicals and fractions. Yeah, this is a really good one. Actually, there's kind of a way that you can do this to get around doing quotient rule. Would you like to know that? Sure. Yeah? You can change this. Yes. You can change this to product rule instead and change that to -1/2. Yes, make it product rule instead. I think that's so much better. So much better than quotient rule. You could do the whole thing to the -1 and still do product rule. But you'll have to do chain rule though.
And then you flip it back, right?
Yeah, at the end. Okay, let's do it then. Here we go. No, because you didn't know about the chain rule. Yeah. See, when we did quotient rule, we did like y equals x plus 2 over x minus 3. You know, something like that, or 2x minus 3. If you change that to be to the -1, you would still have to multiply by 2, and we didn't know chain rule. All right, you ready? Let's do it. Product rule. So this is A, and this is B. So we're going to do A times B prime. So x times, here we go. This right here is chain rule. There's an outer function of to the -1/2, and the inner function is 1 plus x squared. So bring the -1/2 down, leaving the inside alone, and subtracting 1 from -1/2. So that would be -3/2 times the derivative of the inside. So you bring the 1/2 down. All I'm doing is the outside part, just the power rule. Now times the derivative of 1 plus x squared, which is 2x. That's the hardest part of this whole thing. Well, maybe simplifying at the end is the hardest. So that's A times B prime plus B times A prime, which is 1. Okay, now we get to simplify this. You ready? So here we go. We've got a 1/2 and a 2. So I end up with -x squared over 1 plus x squared to the 3/2. You can write that.
Can you like go through how you're doing this?
How I'm doing it?
Where are you starting?
I'm simplifying this right here.
Mm-hmm.
So I have a -1/2 times 2 is -1.
Okay.
X times x is -x squared. So this is all just the algebra part of it, right?
Is 3 over 2 the same as 3 times rad 2?
It'd be rad 2 cubed.
Okay.
Yeah.
So then it becomes x times negative 1 plus x squared to the negative 1 half, right? Times x. And then, because you like kind of skip that middle, like simplification step.
I didn't skip anything. No.
You just didn't rewrite it.
Rewrite what?
Okay. After you like canceled stuff out. That's all I was
Oh, we canceled the 2. Negative 1 half times 2 is negative 1. X times x is negative x squared. I didn't skip a step. I wrote it down. Right? Nobody likes that one?
Yeah, it's fine. It's okay.
You know, and you can actually simplify this. I'm not really picky about it though. This is 1 plus x squared.
Why is that not a negative 1 half at the top for the b term?
For the b term?
Yeah.
Oh, it should be. You're right. Thank you. I knew something was wrong. This should be to the negative 1 half right here. Thank you. I know, I kept looking at it like this isn't right. I know it's not right. And this is cubed plus 1 over 1 plus x squared.
So there's no square root there?
There we go. No square root where?
In the second thing? The second, no, yeah, there's no square root there?
Yeah, it's to the negative 1 half. I accidentally wrote 1 half down. So it's b times a prime. So it's to the negative 1 half, so you move it down, and it becomes the square root of 1 plus x squared. And this is fine. The book actually kept going and simplified it a little bit more, but that's good. That's good for our purposes. They actually combine these two fractions together. Yeah, it's pretty bad. Yeah, you can leave it just like that.